Hope you are able to see the screen. Okay.
Yes.
Yes, sir.
Okay, good. So as you know, Canoi tool. So in the Canoi tool, where we have the panel, and in the tools we have the CAPl browser. So this CAPl browser here.
90% ना हाताने को बोलेगा 10% बोलेगा
Sorry.
पाम करायचं पामच्या उत्तीनं ऑपरेशन
On
करायचं
start.
3 बोलते फिरने का पानी
On start.
पी पोसो बी खा गया का ते
Someone
पाम
can mute, please. Okay, on start. So as I told you, like in the CAPl, we are writing the right. Okay, we should write. We are using the right for printf. Hello. Hello, start. So this is a simple program to print the variable. Okay, so we need to save this file. So I'm saving this as a programming one. Okay, so after saving this, what I need to do? So we have the simulation setup. Here, this is the simulation setup. I need to create the SG block. So interactive generate block. This is for sending of the messages. Okay, and we have other platform insert network node. Okay, we should not use this IG block. IG block is specifically for the sending of the messages. So now I need to add the file CAPl programming. Okay, for that what I need to do, so just click on this ECU. It will ask you the you need the can file. So that is a file, the program one I added. So I will run the Canoi. So after running the Canoi, in the right window, I will see that hello, welcome for the CAPl program. Why it came? So the program which I wrote now, so it will be okay. So this is the one. Hello, welcome for the CAPl learning. So just I given this info. Okay. So here in the CAPl right window, we can see the info. Okay, there are other programs. Suppose I need to send one message. Okay, so for that, what I need to do? So okay, on start, I need to send one message. Okay, so on start, I need to send one message. Okay, for that, if I say that message is message mg1. Okay, so mg1 is the one message. Just example I created. Okay, so if it make it as 055. Okay, just a ID and the message. Now I need to send this message. So for sending the message, this is the functions. So output mg1 output. If I give this message sent, successfully. So message sent successfully means, so whatever we are defining the message within the variable on start is the Canoi. We are on start, and output is the message. It will go. Okay, so means it will go into the ECU, and this is the information. It will be a printf. Okay, so for that I created the and saved it. So I need to compile this. There is no errors. So after compiling, here in the Canoi, so I need to reload this. I need to select this. Okay, it is already compiled. So if I send, so message sent successfully means whatever I given, the message is output and message sent successfully. But how I'll come to know whether the message is sent successfully or not? In the trace window, I didn't find any message. Okay. But whatever I defined in the CAPl, okay, the 55 and message one, that only I can see here. Okay, so that is a message is ID is 55 and the can frame and TX is 2 bytes. Just it is taken 2 byte. But there are some messages. Okay, so that messages I have it in database. Okay, so how I need to access that? So here we need to go to the simulation. So in the simulation, I have the database. This database contains all the messages and signals information. Okay, so now I need to access that messages. Okay, so for that, how I can do it? Message. So if I enter a small space, so I will get the message signals. So Intel Vision is a one signal, the CAN message signal. And need to add the message. Okay, so here we have the messages, the front door status. This is the CAN message, and where we can add the signals and messages also. Now just I'm adding the only the message because need to know the messages information. Okay, for that I will create the message and just I will define it as a message one. Okay, so now I created the message and message one. What will happen? So it have some bytes of data and the signals. So that message can be transferred in the network. Okay, so I updated just message here and compiled. So there is no warning, and I will run the CANoE. So where you are able to see the message and the bytes of data. That is this message contains the 6 bytes of data. So it will be there only 6 bytes. Okay, and the message signals, it have the signals, so it is disappearing. Okay, means the message sent one time and it is disappearing. Okay, so again I started the CANoE. After some time it is disappearing. It is only one time. The message contains all the message signals also. Okay, so if I need to send the message, I can do send the message. If I need to send only the signal, okay, so I can add the signal. Okay, like I need to add the Intel Vision signal here, the message one, and now I save it and I will compile and just I will run on the CANoE. Okay, so what it will do, it will send only the specific signals related information. Okay, these are usually selecting of the messages. So here the message I selected, no, it will consider only the messages. Okay, that's how the message we can transmit one time with the help of the CAPl. Like if I need to transfer two messages, what I need to do? So here message, okay, and I need to select the message from the database. Okay, and that is MG2, and in the on start I need to give the output MG1, MG2. Okay, MG2, just this and save. 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 After saving this, just you need to rerun the CANoE. So now the two messages are came on the CANoE tool. Okay, so now I need to make it 3 messages because we are not sending one by one manually by creating the IG block. where we have the CAPl. In the CAPl, where we can make the messages at a group of messages at one time, and we can transfer the data. So like this MS sheet 3. So if we need to save it and compile and go to the CANOE and run. So the 3 messages are visible on the trace window. Okay, this is how, but it is only for staying for some time, but I need the messages continuously on the trace. Okay, and there are other points as well. So I need to update the data periodically. Okay, so just we'll make it one program for clear understanding. Okay, so I will remove the other stuff. So if there is a here we have the variable, and here we have the message, and I have the data. So how we can define this? So we can define like equal to the DLC. So DLC means the 1 byte of data I need to update periodically. Okay, so this is the DLC. So here we usually give like, we'll define 1 byte of data. So that 1 byte of data, it need to update cyclically. Okay, so the output of the message here, it will be like this. So on start, what it need to do? So for the byte update, we need to write like this: msg1 dot byte of, I need to update the first byte. Okay, so for that I need to write 0x a. If we say this is a byte, okay, so if we give a, okay, so this byte first I will update. Just I need to transfer this. Initially it was 00. If we go to the trace, this byte is 00. Okay, this signal intelligence switch, that switches this signal, intelligence signal, it is, there is 00. Okay, now I need to update the 00 to a. Okay, so now I need to transfer a. So just I will save this and compile. There is no error. And what I need to do, like I will run the CANOE part. So now here it updated the a. Okay, so a is the data, one data it is updated. Okay, clear, right? So now the 1 byte of data is updated here, but I need to update this data periodically, like continuously. I need to update, means whatever the message you are seeing for some milliseconds of time, I need to be continuously, the message should come here. So how that I can update? So for that, what I need to do, so like the message, so here we need to use the timer. Okay, that timer is ms timer. Okay, so that is a t1. I will define it. Okay, t1 ms timer. Sorry, ms timer, that is a millisecond timer. So just I given as a t1. Okay, so and next is on start. On start, we need to give the initial timing. So here it's not, it will be in the different space. On start, set timer, because we defined the timer, no? So here we need to set the timer. Set the timer. Timer 1, 100. Timer, we have defined the timer. We initialize the time here. like 100 milliseconds. So because milliseconds is ms. Now what I need to do, so I need to once the timer is on, means here I need to define it on timer t1. So on timer t1. Now this message will update cyclically for every 100 milliseconds. So compile, there is 3 warnings we are getting. Okay, good. So timer here I don't have, but here we are getting set timer. So we need to give set timer. Okay, so the space it was there, so that's the reason. And we'll see whether it is compiled. There are 2 warnings, so it is coming here. That is on timer t1. Okay, so next here we don't have the errors or 0 warnings, so it is got compiled, and we'll go to the CANoe and we'll run here. So now if you see, the message is updating here 1, but it's not happen, it is happening only one time. Okay, why means initially it started initialized here, but as defined the on timer, but if within the on timer we need to reset the time. This means whatever the time we are defining the set timer, within this we need to give. Okay, now save this and compile. There will be no errors, and if you see now the messages disappear here, and go to the CANoe, and now if you see the timer, if you see the timer, it is updating every 100 milliseconds. So the switch signal came here, the message, and yeah, we updated has the Intellivision switch. So the switches came here and it is updating continuously. Like this is the periodic message or repetitive message that will update. Okay. So like this, the message will keep on update in the trace window. Similarly, I need to send hundreds of messages. Similar, in that case, we need to create the messages or signals in such a way, and we need to set it. Okay. So suppose I have 2 messages. Okay. So where the 2 messages are defined here. Okay. So if you observe, okay, let's make it 2 messages. So the 2 messages, I will remove this. There are 2 messages. I will keep it as a friend door, and this is a message too. And the DLC, just I will remove it because I need to update enter message here. Complete message I need to update. So in that case, I will create the output as MSG2, and so now this MSG2 is there, and I define the 2 messages. What will happen now? So it will first the message, it will be update the data AA, and other message it will update only the information, but it will be in a periodically the messages will update on the window. Okay, so if we'll start the CANoe, so if you see, if I didn't define that the message data here DLC, so without DLC just the message came, but the 2 messages are updating the timing with the same, because I defined the time, initialize the timer 100, and within the timer I given the 100. Because of that, the 2 messages what we are transmitting now, so it update periodically on the trace window. Okay, suppose I need to send this one message at 100 millisecond. Okay, and this message, the another message I need to send it 50 milliseconds of the time. If you see, now it is updating in the same timing, but I need to change the timing of these two messages. How I can do it? So we need to define the timer of ms timer to, okay, so ms timer t2, and I need to give the another timer also here, the t2, and the timer here I need to take another step of on timer set to, and as I told you, we need to give the 100 milliseconds and 50 milliseconds here, and here I need to give the 50 milliseconds, and here I will give the bb for the second message, and here I will remove msg1, and here I will keep msc1. Okay, message 1 sent successfully, message 2 sent successfully. Now we'll save this, and
So we change the T2 T1
T2 it's changed.
set timer.
Yeah. Thank you. So now it is saved, and just we'll compile it. There are no errors, and we'll stop the canary and we'll send it again. So if you see here, there is no updation is not happened. Okay, so some mistake is there in the code. Message 1, message 2 on start. So here we should get AAA is updated. This is the message 1, and B we need to get
Message 2, it is MS2.
sorry, message 2.
Here, in the second line. After set
Yeah,
time.
this,
No, before that line.
yes. Because of that, we didn't got that message in message 2. Okay. So now if you see, this should update. I will start Canonian on. So if you see, this message to BB is coming, and message 1 we got the EA. So this is updating periodically. This is updating 100 milliseconds of time this time, and this is updating 50 milliseconds difference. Okay. So how we usually observe the difference is, so we have the here the difference view. Okay, so just we need to pass this message, and we need to select the same message, two different messages at a time, and we need to see 0.05 means 50 milliseconds. So this is the difference between the two messages. Okay, like that, or the difference whatever we are giving configuring in the input, that can be monitored here. Okay, so this is the two different messages how we can send periodically, and how we need to update the messages with the different bytes of data. Okay, so these are the very important programs, so the basic concepts. And now I mentioned an on start. This is a on start one. Like I will mention on key. On key, if I specify that a. Okay, so this is a keyboard. Okay, if you enter the key value, the message should send. Okay, so just what we'll do, I will stop this canary, and it is already compiled, and I will turn on the canary. There is no messages here. Okay, I will press the key A. So now the messages will come on the canary. So this is how the on key will work. I am entering the key specifically. Okay, so now I don't want to enter a key here. Yeah. So I need to enter any key in the keyboard. I need to get the data. So how I will do that? I will make a start there. So if I enter any key on the keyboard, it should get it. Okay, but something is here I defined a star within the braces, no? So we need to give the star only, then only we'll get. Okay. And when we are giving the syntax, it's very important. We need to give star separately, so then it will access us to enter any data, like it will accept any keyword from the keyboard. Okay, so just compile it here, and I'm running on the canary. So if I do this, I will enter the keyboard of the data. Like suppose if I enter now E. Okay, E I entered, it is coming. Somewhere you need to monitor this value here. If you see here, I will check update randomly, like pressing of V updated. And now if I press the value of P, whoa, I entered, so just a message came. And if I enter the K, so the message came, means whatever the keyword that we are defining, like star, it will take any keyword from the keyboard. Okay, so that is the on key. So when we are entering something, so that it able to access the data. Sorry, it able to send the data, and it will able to access the data. So this is about something via output. Okay, so for reading of the information, okay, we have a get value and put value. So and that get value is specifically will define here, and the message information. So that get value will read the data. So how we usually define, so there is a message, it is coming from the ECU. So we usually write like A equals to get value. Okay, so that get value, it will take the read the data from the specific message signals. So okay, so when we are writing something here, we need to always define this int A. Okay, so if we define, we won't get any errors in the program. Okay, so this is all about the CAPl basics concepts, and very important concepts. Okay, and moreover, we need to check the conditionally, or like whatever the value that we are sending to the canary, it is periodically correct or not. So in that case, we are using the um, key sorry, like if else condition statements. Okay, so as I told you about the environmental variables, so how that environmental variables we are creating. Okay, so so if these environmental variables are created for the, especially for the uh, switches. Okay, switches are the indicators from the simulation panels. Like in the canary, we usually create the simulation panels. No, for that we usually create the env. So env is the environmental variable. Okay, only for canary. Okay, so that is the switch. If we say switch, and if the switch is on, if we say the switch is on, until switch equal to 1, then okay, set okay, output the message 1. Okay, else, or else right window, message not sent, message not sent. So just these are the basics info, like how we are accessing the switches or environment variables with the help of this. Okay, and suppose you need to know about the switch information. Okay, you need to read the switch information. You are writing the code, but how you need to do that is so int a. So I will define int a. Okay, int a, that a equals to get value this, and come on, right
Value.
flow
Release.
yeah
Value.
yes. Switch information, switch info, just I will write like this, a. So